Hey, what's up guys? This video is for section 9.3, which is transformations of quadratic functions, but it is part 2 for this section, and we are going to graph those quadratic functions when we have a transformation, and it's in vertex form. The quadratic function is in vertex form. So let's look at some examples of what we can follow to graph those functions. So when you guys want to graph a parabola or a quadratic function, it is in vertex form. You have to understand what the form is first of all. So the vertex form is y equals a times the quantity of x minus h squared plus k. This y can be f of x as well. F of x is the same thing as y. But you guys have this form right here with the parentheses squared, and you have a number inside, number outside, and the a. So the first step is to find your vertex. Now to find the vertex, we need the h and the k, so that's the number inside of the parentheses and the number at the end. And you guys have to remember a couple things. Number one, you always change the sign of h, so h has to be the opposite of what's inside of the parentheses. K, you always keep the sign. If you guys want to find the minimum or maximum value, well, that's going to be your k value in your vertex, which is the same thing here or here. So y, for the min or max, y equals your k value. Step number 2, you need to draw your axis of symmetry through the vertex, and it's going to be a dashed vertical line through the vertex. And if they ask for the equation of the axis of symmetry, well, your equation will be x equals your h value, which is the one here. And step number 3, you guys will follow the pattern 1, 1, 2, 4 from the vertex to make 2 points, reflect the points on the other side of the axis of symmetry, and then you guys connect the points to draw your parabola. Now the steps are very similar to when you graph a parabola or quadratic function in standard form. Standard form is y equals ax squared plus bx plus c, but the way you guys find the vertex is a little bit easier when it's in vertex form. It's kind of already given to you. The axis symmetry is still the same as standard form or vertex form, and the pattern is the same, 1, 1, 2, 4. So we are going to use those same steps, but it is in vertex form. So I'm going to start with the parent function of how to use the vertex form and the steps to graph this function, and then we're going to move on a little bit more with more numbers, and eventually we're going to get the whole vertex form. But now if you guys look at the function f of x equals x squared, keep in mind f of x is the same thing as y. When we look at the function, we don't have a parenthesis and we don't have numbers at the end of the function. So let me just write down the actual vertex form again so you guys know what we are looking for. So my vertex form, f of x is a times x minus h, quantity of x minus h squared plus your k value. So when I compare the parent function to the actual form, I don't have parentheses, so there's no h, and I don't have a number at the end. Now you guys can say that h equals 0 because we don't have a parentheses. So let me write that down, h equals 0. And your k value, well, at the end of this one, you can say there's an invisible 0 plus 0. And let me just put that down so you guys know that here at the end we have a plus 0 at the end. So k is going to be your 0 value. Now you can say the same thing about h. You can say inside you guys have a minus 0, but that's nothing, so h equals 0. Your a value will be the one in front of the x squared. So my a value is 1. So a equals 1. So that's good because it helps us to know that when a is positive, the parabola is going to go up. There's no reflection across the x-axis. And since a is 1, our pattern is going to stay the same. So let me refresh your memory with those patterns. And like I said, guys, this is the same thing as when you guys graph in standard form. So you guys don't remember, you can go back and watch that video to understand the pattern. But let's go ahead and follow the steps. So step number 1, I want to know what is my vertex. So my vertex will be at h and k. So h is 0 and your k value is 0. So my vertex is at the origin. So I'm going to put the origin right there. That is my vertex right here. I know the parabola is going to go up because the a value is 1. But step number 2, I'm going to draw the axis of symmetry. And my axis of symmetry is a dashed line, and it's going to be through the vertex. So the dashed line through here, I got my axis of symmetry. Now the next step is to actually find the equation of the axis of symmetry. So the axis of symmetry, x equals your h value, and in that vertex h is 0, so you're going to put 0 for h. So that is my equation, x equals 0. Now the next step number 3, you guys are going to use a pattern. Now this is vertex form, so we don't need really the y-intercept in vertex form as like the standard form. But if you guys want to use the or find the y-intercept, you guys can substitute a 0 into the x here after you know what h and k is and the a. You substitute a 0 here, you're going to simplify, and you're going to find the y value, the y-intercept. But right now we don't need it. We're just going to use the pattern. So for the pattern, I have my cross here that we use. I put 1, 1, 2, 4, and that is the pattern, 1, 1, 2, 4. My a value, I'm going to go back here. It is positive 1, so that means I don't have to multiply those numbers. If a is not positive 1, we're going to have to multiply the 1 and the 4 by the a value. But right now, it's okay. So from the vertex, you guys go 1 step to the right, 1 step up. From the vertex, 1 to the right, 1 up. And you guys make a point right here. And again, from the vertex, you go back, and now you go 2 steps to the right and 4 up. So from here, 1, 2, 1, 2, 3, 4. So you guys have another point right here. So the next step is you reflect the points. So this point here is 1 step away from the axis of symmetry. So on the other side, 1 step away, I'm going to plot a point. And the other one is 2 units away, 2 steps away from the axis of symmetry. So on the other side, 2 steps away, right here. So you make another point, and now you guys connect the points, and you guys have your U shape. So we have a parabola going up, and we have the vertex at the origin. So now let's go ahead and look at this function here. F of x equals negative 2x squared minus 3. Notice it looks very similar to the standard form. The only thing missing is the bx term in the middle, but since we are missing the b, we can actually use the vertex form, and that's going to make our life a lot easier because vertex is h and k, and it's kind of already given to you in that function. So let me write down the function again, the vertex form, so you know what we need to look for. So we have this vertex form here. You guys want to compare. So first of all, we need the vertex, step number 1. And for the vertex, I'm going to put v here for vertex. I need the h and the k. Now the h is the one inside of the parentheses, so that's the number here. And you guys do not have a parenthesis here. So that means that we have 0 for h. K is the one at the end, and it's this one here, minus 3. So this one, I'm just going to label that for you guys. This number here is your k value. So negative 3. Now your a value is the one in front of the x or the parentheses, but we don't have parentheses, but it is in front of the x. So a is negative 2. A equals negative 2. So how does that help us? The a, since it's negative, you guys have a parabola going down. It is a reflection across the x-axis, and we talked about negative a on the previous video for transformations. So it has to go down. And for the pattern, we will need to multiply the numbers 1 and 4 by a, which is negative 2. But let's go step by step. Step number 2, you guys will have your axis of symmetry. Oh, I forgot to plot the vertex. Let me do that right now. 0, negative 3 is right here. So that is my vertex. My number 2, step number 2. Now I go to my axis of symmetry. So I'm going to make my dashed line right here through the vertex. So notice it is a dashed line, and that's going to help me actually reflect the points on the other side of the axis of symmetry when I find 2 points. But let's write down the equation. X equals your h value, 0. Remember, your h here is 0, so that is your axis of symmetry, your equation. Step number 3, we are going to use a pattern. We have a cross here, 1, 1, 2, 4, and my a value, let's go back, -2. We're going to have to multiply these two numbers by that value because the transformation is going to change. We are going to transform. When you have a negative or greater than 2, that's a vertical stretch, and it's going to make your parabola narrower because the 2, a equals absolute value of a is 2. So I'm going to multiply by -2 here, so that equals -2, and I'm going to multiply by -2 here, and that's going to be -8. So I'm going to plot the points from the vertex. Let me go back to the vertex here. I go 1 to the right and 2 down because it is a -2 here. So 1 to the right, 1, 2, and I make a point right here. And for my second point, 2 to the right, 8 down from the vertex. 1, 2 to the right, 1, 2, 3, 4, 5, 6, 7, 8. And there is your point. So now you guys will reflect on the other side. So this point here is 2 units away. So on the other side, I'm going to plot the point. I'm going to reflect 2 units away. So my point is here, and the other one is 1 unit away. So on the other side is 1 unit. So I reflect the point right here, and I connect the points, and we do have the parabola going down, and we have ourselves the graph. Now going back to the function, let's talk about transformations. You guys have f of x equals -2x squared minus 3. So look, when you guys compare to the parent function, the parent function is the one with just an x squared, f of x equals x squared. Well, this one has a -2. The negative, I already mentioned it, but I'm going to say it again. The negative a value tells you that it is a reflection across the x-axis. So in other words, it goes down, but the terminology is reflection across the x-axis. The number 2, the absolute value of -2 is +2. So that number 2, since it's greater than 1, you are going to have a vertical stretch. So the graph will be narrower. And the value of k, this number here, -3, tells you guys you move the graph 3 steps down from the origin, which is the parent function. So that makes sense, guys. The parent function goes up like this, and let me actually do one to show you guys what it is. Let me just make it like a highlighter. It is a U-shape going up like this. You probably can't see that. Let me do it purple. So we do have a parabola going up like that. It is the parent function, but you guys reflect it. Now it's going down, reflection across the x-axis. You guys have a narrower, skinnier parabola. This one is a little bit wider than this one. So it is narrower because of that 2. It is a vertical stretch. And you move the vertex 1, 2, 3 steps down. So there's a lot of transformations happening in this function. And that's what helps you guys know what's going to happen to the parent function. So let's try this one here. You guys have f of x equals parentheses x minus plus 1 squared. So first, let's talk about the transformations. When you guys know what the numbers are inside of the parentheses and outside of the parentheses, you guys will understand the transformation. So first, a is the one outside of the parentheses here. So we have a equals 1. So there's no vertical stretch, there's no vertical compression. It's not narrower, it's not wider. It's just the same as the width is the same as the parent function. This number here is your h value. So I'm going to put it here, h equals, but here's the thing. For the h value, you have to change the sign. So that plus 1 becomes a -1. And your k value is going to be at the end. Now, right here, we don't have a number. So you can kind of say plus 0. But again, guys, that doesn't need to be there, the 0. But that's true. You guys do have a plus 0. So k equals 0. So what can we say about the transformations? The width says the same, so we don't say, and it is positive a, so we don't say vertical, a reflection across the x-axis. H is a -1. So what that says, you move the graph to the left 1 step. So from the origin, you go 1 to the left. And your k value is 0. So from here, your K value tells you if you go up or down. That's your vertical translation, up or down. So since it's 0, you stay right here. So from the origin, you go 1 to the left. You don't go up, you don't go down. You stay right there. So that's your transformations. But now we need to actually graph the parabola. So step number 1, I'm going to look for my vertex. And my vertex is my h and my k. So remember, h is -1 and k is 0. So let's go ahead and plot that point. -1, 0 is right there. Step number 2, I'm going to do my axis of symmetry. So it is my dashed line through the vertex right here. So it is my axis of symmetry. It cuts the parabola in half, and it's going to help us reflect the points on the other side. Let me just label the vertex for you guys. Right here, there's the vertex point. The equation is x equals your h number. So h value is -1. So the axis of symmetry is at x equals -1. And then you guys move on to step number 3. Step number 3, we do our pattern 1, 1, 2, 4. And I notice my a value is +1. So I don't need to multiply the 1 and the 4 by anything. You don't have to, because if you multiply by 1, they're not going to change. So when a is +1, you don't have to multiply. But you do have to follow the actual pattern. So from here, from the vertex, I'm going to go 1 step to the right, 1 step up. So I make a point right here. And from the vertex again, 2 steps to the right, 1, 2, 3, 4 steps up. So right here. And I'm going to reflect the points on the other side. So I'm going to start with this one, 1, 2 steps, 1, 2 steps. So right here. And the other one, this one is 1 unit away. So on the other side, 1 unit away, right there. So I make my U shape, and I have my parabola. It is going up, a is positive, and the vertex is at -1, 0. All right, now this one has more things. It actually has the a, the h, and the k in one function. So I'm going to show you guys how does all that work in your vertex form. And then we're going to graph the actual parabola. But first, let's talk about the transformations. You need to understand what's going to happen to the parent function. So let's look for the a value. Your a value is the one in front of the parentheses. So a equals -2. Your h value is the one inside of the parentheses. And remember to change the sign so the -2 becomes a +2. And we do have a k value here, which is the last number. K equals +3. Oops, I did put a k right here. It's supposed to be an h. So let me erase this and do this again. We're supposed to have h equals a +2. So that's h, and your k value is +3. So let's talk about the negative a value. Negative a is a reflection across the x-axis. In other words, the parabola is going to go down. Your absolute value of a, -2, absolute value of -2 is it's 2, more than 1. So when the a number, absolute value of a, is more than 1, you have a vertical stretch. So the parabola is going to be skinnier than the parent function. H tells you guys are going to move 2 units to the right. And K tells you guys you move 3 units up. It is positive, so you guys go up. So from here, from the origin, you go 1, 2 to the right, 1, 2, 3 up. And that's going to be your new location for the parabola. Not the origin, that's the parent function for the vertex, but we have a transformation. So let's go through the steps. Step number 1, you guys are going to have your vertex. So my vertex is at h, which is 2, and k, which is +3. So from the origin, 1, 2, 1, 2, 3 is right here. So let me label that for my vertex. Step number 2, my axis of symmetry. And remember to do your vertical dash line through the vertex. So here we go. We have a dash line right there. And we cut the parabola in half. And that's going to help us reflect the points on the other side. Now, the equation of the axis of symmetry, keep in mind, x equals your h value. So that's going to be a 2. So x equals 2. And the third step, we use a pattern. 1, 1, 2, 4. But let's go back to the a value. Notice the a value is a negative 2. It's not positive 1. So that means is we have to multiply by negative 2. So the 1 times negative 2 is negative 2. And the 4 times negative 2, which is negative 8. So we're going to move 1 to the right from the vertex, 2 down, it's negative, and then 2 to the right and 8 down. So from the vertex right here, 1 step to the right, 1, 2, 3. Oops, I went too far, sorry. 1 to the right, 1, 2 down. So we have right here. And then the other point, 2 steps to the right, 1, 2, 3, 4, 5, 6, 7, 8. So we have right here. And now I'm going to reflect on the other side. 2 units away and 1 unit away from the axis of symmetry. And I have my parabola right here. So it is going down. Notice it's skinnier. I know you guys can notice this just by looking at the graph, but it is skinnier than the parent function. And it is a reflection across the x-axis because it's going down. All right. So I have one more to show you guys. We're going to talk about the transformations and everything else. So let's look at the last one for this video. F of x equals 1/2 times the quantity of x plus 1 squared minus 4. So first, let's look at the a, the h, and the k. Your a value is going to be the one outside the parentheses, before the parentheses. So a equals 1/2. I'm just going to put an arrow right here. Your k value, not k, sorry, your h value is going to be the one inside of the parentheses. So h equals, remember to change the sign, so that plus 1 becomes a negative 1. And your k value is the one at the end. Never change the sign, okay? So we have k equals negative 4. So let's talk about the transformations. A is positive, so there's no reflection across the x-axis. It's going to go up. But it is 1/2. The absolute value 1/2 is 1/2. That's less than 1. So when the a value is less than 1, the absolute value of a is less than 1, you guys will have a wider parabola than the parent function. So it's going to be wide open, wider. This one here, it tells you guys you are going to move 1 unit to the left. Let me write that down so we know what's going to happen. We are going to move 1 to the left because it's negative h, negative 1 unit to the left. And your k value, it's negative 4. So that is down. So you guys will move 4 units down. So we know what's going to happen to the graph. The graph is going to be wider. It's going to go up. And we move 1 to the left and 4 units down. So let's follow the steps. Step number 1, we need the vertex. So my vertex is h and k. So h is negative 1 and k is negative 4. So at negative 1, negative 4, negative 1, 1, 2, 3, 4 is right here. So that is my vertex. Step number 2, you guys do your axis of symmetry. So I'm going to do my dash line. Notice dash is going up and down. It is a vertical line, and it cuts the parabola in half. So we are able to reflect the points. The equation of the axis of symmetry is your h value. So negative 1, I put right here. And step number 3, you guys do your pattern. 1, 1, 2, 4. But be careful because we do have an a value that is not 1. It's 1/2. So you have to multiply the 1 and the 4 by 1/2. So let me multiply this one by 1/2. Multiply this one by 1/2. And you guys will get 1 times 1/2 is 1/2. Let me make a decimal form because we are graphing. Every time you guys graphing according to plane, it's a lot easier to use decimal form. So this is going to be 0.5, and 4 times 1/2, that equals to 2. So from the vertex, from here, I'm going to go 1 to the right, and then I go 0.5. So half step up. So it's going to be right here. It's not going to be exact, but it's going to be more or less right there. And then the second point is 2 to the right and 2 up. So from the vertex, 1, 2 steps to the right, 1, 2 up. So that's going to be right here. Now we can reflect this point, 1, 2 steps, 1, 2 steps from the axis of symmetry. And this one here, remember, it's between the negative 4 and the negative 3. So it is 1 unit away. So on the other side, 1 unit away is right here in between. So that is my reflection. you guys are going to connect the points, and we have our parabola. Now again, guys, it is hard to see the parent function, but this parabola here, it is greater, it is wider than the parent function, and you guys have, because the a value is less than 1, it is wider, and the parabola is going up. All right, guys, so guess what? I do have one more example. I know I said this is the last example for this video, but I remember I have one more example. It's not about graphing, but it is about the domain and range and the minimum and the maximum. You guys really need to know which one is domain and range. So just to give you guys an idea, the domain and range, let's talk about domain and range here. We can actually use this example, and then I'll do the other example on the next slide. So domain, when you guys have parabolas, my domain is all real numbers. You always want to say that for any parabola, it's all real numbers. My range, that depends on the vertex. Range are your y values. Domain are your x values. So for domain, when we say all real numbers, that means that x values, any x values, actually work for the function. But your range depends on the y values. So when you're looking at the vertex here, there's a -4 on the y value. You guys can see that on your vertex, -4 here. The parabola is going on top of the -4. So your y values are greater than -4. All the numbers on top of the -4 are greater because you guys have the +1, the +9. Those are greater than -4. So your range will be y is greater than or equal to, and I'm using a y because that's your range, greater than or equal to because the parabola is going on top of the vertex and it goes through the vertex. That's where the equal to comes in. And -4 is your k value or your y in your vertex. So that is your domain and range. But let's do one example next to talk about the domain and range again, and the min and the max. Alright guys, so we have this function here, y equals -2 times the quantity of x plus 3 squared minus 5. So in order to find the domain and the range, first of all, we need our vertex. So my vertex is going to be my h and my k value, and that's where you need to know your h and your k. So h is right here, h equals, change the sign, -3. K is the one at the end, never change the sign, so that's going to be -5. So my vertex is at -3 and -5. So h and k. I'm not going to graph it, but I'm going to show you guys how to find the domain and range without graphing and the min and the max. So my domain will be all real numbers because for any parabola, any quadratic function, any x value works in that function. So all real numbers will work. My range. Now, looking at your vertex, the range, you need a y, and we need to know if it's less than or greater than, and then we're going to use the k value or the y in your vertex. And that's where the a comes in. So let's talk about a. A is -2, which is the number right here outside of the parentheses, before the parentheses. So that means the parabola goes down. If the parabola goes down, we are going to use a y is less than or equal to for your range. If the parabola goes up, you guys will use a y greater than or equal to for the range. But right now, a is negative, so it has to go down. So my y value or my k value for the vertex is -5. So I'm going to put -5 right here. So my range is y is less than or equal to -5. Now, since the parabola is going down, and let me write the word down so you guys know and give you guys an idea. The parabola has to go something like this. That's not my actual parabola, but it has to go down. That means that we have a maximum point. So let me put max right here. And my maximum point is the actual y value on the vertex. So the vertex y value is -5. So my maximum point will be -5 as well. And guess what? That's where the range starts, at the maximum point, -5, -5. So we do have domain, all real numbers. My range, y is less than or equal to, because it's going down, -5. And then it is a max, because it is a maximum point when you guys have the parabola going down. If the parabola is going up, then you guys have a minimum point. And we talk about those minimum and maximum on my previous videos, so check out that standard form for quadratic equations, and you guys will understand min and max. So this concludes my video, guys. Make sure that you guys practice, and if you guys like my videos, you guys can hit the like button. If you guys can also subscribe, and I'll see you guys later.